Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Bommer number 7813 HD-652. This is Bommer's heavy-duty double-acting floor pivot hardware. And let's dissect the part number a bit. First of all, 78 stands for the series of double-acting pivot hardware from Bommer. 13 indicates that it is 13 HD indicates that it is both non-hold open and rated for doors up to 150 pounds, which separates it from the lighter duty models, which are available as well. The 652 means that the exposed hardware is in a satin chrome finish. So the exposed hardware will be primarily the two base plates that get mounted to the face of the door, but cover up the assembly, okay, like that, obviously on both sides. There are additional pieces that are included with the unit, and we're going to go over all of that next. Now, in order to do that, I'd like to go through the template. Let's take a look at the template, which is a link below this video. And the template, along with the instructions that are also listed below, there's two links. Let's look at the template first. The template is a dimensional drawing showing everything important about the item, okay? And on it, there are dimensions for every aspect of the item. But as I'm looking at it, I'm realizing that there's nothing on it that is specific to the installation aspect or preparing the door and frame for installation that are not already covered on the instructions. So at this point, let's focus on the instructions. The instructions will come included, and that link is below this video, and this is what they look like. Okay, so let's go through that now. First of all, step one shows an 1.5-inch radius that they want you to round off the door at the pivot side to allow for clearance. So that's usually the first step of, and that is the most complicated step of installing this, to get that 1.5-inch radius on the door. So if you're ordering a door from a door manufacturer or from your door distributor, you'll want to order the door like that, because who's ever manufacturing the door will be capable of doing that sort of radius treatment to the vertical style of the door. Now, Bommer is saying round off the edge of the door at the pivot side to allow for the proper clearance. It's most likely that you would want to radius both styles of the door. So here's the logic of radiusing the style. If the palm of my hand is the jamb and my fist is the square edge of a door, you can get the idea that if you have a square edge door, you're going to have a conflict where the door cannot open properly because there's no clearance. But when you radius the door edge over, all of that becomes no longer an issue, because the door is allowed to have a very tight margin and then to double act without having any conflict with the jamb. And it's rounding or radiusing over those outside corners of the vertical edges of the doors that allows that. 1.5-inch radius. That means that you've got a 3-inch diameter roundover bit. That is a large bit. That's the next step of saying, wow, that I don't know how, where do I even get that bit? I hear that question often. Well, they certainly do exist. They also are certainly very expensive and, difficult to justify for a single job or a single door. If you're in a door production setting, a carpentry shop, you do these doors, you'll have one of those. But the truth of the matter is, if you're doing one door one time and you have an existing door, well, you might have a problem with being able to do that because you don't have the tool. Now, the way that I've done it, being in a small shop setting or doing it time to time when preparing for this sort of hardware, is I had a 1.5-horse large router, and into that I would have a 3-inch carbide roundover bit. And I would lay my door down on sawhorses, and I'd clamp it down, and I would take my tool with the bearing set to the proper depth so that I will get a very symmetrical roundover on the one side, because you're going to do the door like this, then you're going to turn it over and do the other face. So I would have the depth of the bit set so that I'd have a symmetrical roundover, or bowl nose. Think of the top row of tile in a bathroom, that's the bowl nose. When you have a double bowl nose, it's a radius. So I'd set my tool there, and I would make one pass, making sure that my router base never left the face of the door. I don't want to tip it forward at all, and make as clear and as constant of a tool path down the edge of the door. And then I would make only one more path just to clean up any sort of waviness that might occur. And also, when you exit the end of the door, you want to make sure you exit straight off. I would then take the door, I would flip it over, and I would do the other side, and then I would turn it over, do the opposite style, then flip it over and do the other face of that same style. Now, when you do a radius like that, you're allowed to achieve a very tight margin between the edge of the door and the jamb. Step 2 shows that that dimension is 1/4 inch. Well, you could certainly achieve 1/8 of an inch with that sort of 1.5 inch radius. And that 1.5 inch radius is appropriate for door thicknesses from 1 3/8 to 1 1/4 inch. However, the 1/4 inch radius is going to be taken into account when you have a door that's thicker. If you had a tighter radius, you would be able to accomplish your margin. If you had a square edge door, you simply need to increase your margin. Now, you can get by with a double acting door like this without a radius edge at all. You simply need to increase the distance between the edge of the door and the jamb in the edge of the door, but on both sides. You need to make sure that your finished opening and your net door width is going to allow that whatever thickness of door to be able to double act and not have any conflict with the jambs. You could probably count on, depending on the door thickness, you're probably going to be somewhere in the range of 3/8 of an inch gap between the door and the jamb on one side. So keep that in mind. That's step 1. If you have any questions about radiusing the door edge over, feel free to reach out to me. I've done it, and I'd be happy to help with that process. Step 2 shows the preparation that's necessary in the top of the door for the top pivot. And this is what it looks like. It's a 2-piece system, okay, whereby you have your door portion, and that's the one with the spindle. Pardon me. Your header portion, forgive me, and then your door portion, okay? And it just goes like that when it's all installed. Now, you can see that looking from the dimensional properties of what's required. It says mortise 1 inch diameter, top of door, and the header, 5/32 deep as shown. Now, when I've done this in the past, I've done it with a Forstner bit. And I would lay out my 3 points of where I need to drill my Forstner bit in the top of the door and the jamb. You can see that your dimension of 1.5 inches from the edge of the door to the center to the center line of the center hole, then 5/8 over to either side of that center line. So that would give me my 3 points, and you're doing it in the center of the thickness of the door. Now take my Forstner bit and just drill down, being very careful not to drill too deep, because you want the plate, you need 5/32 deep, but otherwise flush. So be conservative, because 5/32 is, just over 1/8 of an inch. So keep that in mind. Now, the bottom portion of step 2 shows where you need to drill the 5/8 hole, and that's going to allow the spindle from the header portion of the top pivot to project into the top of the door. And that's all referencing that 1.5 inch dimension from the edge of the door to the center of that hole. It says prepare 1 inch diameter cutout on the top of the door and header. Prepare 1 inch diameter cutout. Yeah, okay, that's what we just discussed. Install the top pivot into the header and mount the top pivot plate to the top of the door. Both the top pivot assembly and the spring pivot in the bottom of the door must be plumb and on the same center line. Okay, so what they're saying is where you locate this, that 1.5 inches off the edge of the door to the center line, must be translated down properly to the pivoting axis of the bottom pivot. That's crucial, obviously. Now, moving to step 3, it basically shows how you're going to cut out the bottom of the door. And the bottom line is, the first time I did it, I looked, what is seemingly 100 years ago, I looked at that and said, okay, all I have to do is make these notches. And, you know, first time I did it, I employed a circular saw and a lot of chiseling and things of that nature. And then after you do it enough, you get, you know, you create yourself a fixture or a template and I would use a router and then clean up the inside corners by hand. So what I resolved at the first time I looked at that, step 3, all I need to do is make my door look like that, and that's the bottom line. All of the dimensions are drawn there. It's very important, very crucial that you're able to, you know, just make that happen is the bottom line. However you're going to go about doing it is the crucial thing, and I've just realized why the template is important. There's a dimension on the template that I'm not seeing on the instructions. And it might come to me in a moment, but I'm not seeing it. The crucial dimension is, well, there's 2 of them, but yeah, they're both here. On referring back to the template, we've talked about how to pre-fit the size of the door based on the rough openings, or the finished frame opening size and the width. But what about the height? Well, those are the dimensions not on the instructions. 9/16 of an inch is your gap from the bottom of the door to the floor, and then naturally 1/8 of an inch at the top. So you're going to be 11/16 total undercut. So if you've got an 84-inch inside frame height, your door's got to be, you know, 83 5/16 net door door height. That's crucial. That should be on the instructions. It's not that I see. So referencing in step 3, you're referencing everything off the bottom of the door, 3 5/16 up. You've got your 5/16 cutout, and then etc. And you make that staggered L sort of preparation on the bottom. The only additional thing that you have to do is make that 1.5 inch long groove for this pin to be able to travel. And I really can't show you that because I can't, with just hand strength, exercise this enough to really show you. It's just that spring is far too stiff to do that by hand. But you have to allow that pin to travel as the door opens in and out. And that's what that little groove is for. They don't give a depth for, oh, they do, it's 1/8 of an inch deep. And you can see that would make sense. That doesn't project off hardly much at all from the bottom of the door. From the top of the hardware, forgive me. Moving on to step 4. A crucial, it's the same dimension. You can see that you've got an 1 3/4 dimension. Now they're referring from the jamb at this point to the center line. And if you're calculating a 1/4 inch margin between the edge of the door and the jamb, that's your 1.5 inches as referenced in step 2. So that center line, the center line of the top pivot and the center line of the pivoting axis have to be plumb. So that axis of pivoting must be completely plumb. That's the crucial point. And it will be. Just follow those directions. At that point, you'll be able to take your bottom hardware and make sure that it fits into what you've done in step 3, and then attach it to the bottom of the door. Once you're sure that, you know, basically this ear down here is flush, this mounting post feature here is flush as well, you'll be in good shape. You've got this portion attached to the header. You've got this portion attached to the top of the door. Step 5, you just take that unit and just slide it in. Get it so that it's set, make sure that everything works, do a little bit of reality test, make sure you're confident that the door is going to work. Then what I do at this point, it says insert the top pivot into the top pivot plate, swing the door into place as shown, fasten the floor plate securely to the floor, adjust spring tension by turning the, okay. Mark the holes down here, get everything marked where you need it to be, remove the door, drill your holes, or drill one and test it and check your other marks, and then get it all. You know, getting those holes drilled might prove difficult with the door when it's attached to the door. Now it says you adjust the spring tension by the tension collar. On this 7813 HD, this is the tension collar, this item right here. It's got a hole in it where you can insert the included tension rod. You can turn that up and down because it's threaded. And as I do that, it increases or decreases the compression on this spring, obviously affecting the door operation. Okay. Step 6 is now to dress it up or put its clothes on, so to speak. You've got your 2 plates. Screws are included for everything. I should have pointed that out. You're going to get screws for all of your hardware, obviously, and a complementary finish where required. And the last thing you're going to end up having also, okay, is your heel plate, which will get installed. There's a machine screw that's included, and that will get on the edge of the door. And by the way, that radius of the heel plate matches your 1.5-inch radius. Then your cover plates naturally dress that up front and back. The important note in step 6: install side plates as shown, attach the back plate. Use top holes and side plates only. Okay, so down here you're not going to have any wood to attach to, and it's often been something that I've questioned: why are there 4 holes when you only need or going to utilize 2? But there you go. Now reviewing back to the template, I do not see, digesting all that information is obviously a very good idea, and I would certainly suggest it as well. However, other than giving you the margin for the height, it is just simply a very detailed drawing of everything that's there. Now, Bommer is a full-line manufacturer of all things double-acting pivot and hinge related, single-acting hinges. They have a full line of architectural hinges as well, which is the largest share of what it is that they do. There's a can't show it to you, you can't hardly but see it, but the Bommer logo is at the tip of my finger. Right above it, it says "Made in USA," a fact that Bommer is quite proud of, as am I to represent them. This is a non-hold open version. You can obviously get the hold open version if you want it to hold open, which is typical. Pivots like this, where I see them installed all the time, are going to be, well, this sort of pivot, being a little bit heavier, would be commonly seen in a restaurant application, maybe a low volume situation, a door between the kitchen and the front of the house, so to speak, where you've got servers coming in and out. And the 7813 and the fact that it's non-hold open tells me that it will be a heavier door, a larger use door, something in that range, up to 150 pounds, 3-foot door. Typically 7 foot is what you'll see them installed on. This hardware I have seen personally installed on residential applications between a dining room and a kitchen, and I've seen them installed decades after faithful service and still working like the day they were put in. Those are the applications where I see these. Bommer's 3029 series of double-acting hinges are far more common and popular, I think, than this hardware itself. But nonetheless, it's a very elegant way to go ahead and solve that problem. So if you have any questions on the Bommer 7813 HD-652, horizontal spring pivot, heavy duty, non-hold open, okay, or any other Bommer product, please feel free to reach out to us. Thank you.